Well, in what may be an ill-fated attempt to go through and do a lecture recording, I'm going to try and get this done. Conversions and why do they matter? So this is a interesting comment, and ultimately what it comes from is an inability to deal with fractions and conversions through that process. So what we want to attempt to do is come up with a process that will always work and allow us to run those conversions appropriately. All right. So how do we go through and do that? First, we get our technology linked up. So we talked about this fractional notation. And so when we're looking at our conversion factors, what we're seeing is kind of an English language interpretation. And then we also have this kind of math, those equalities. Those equalities can be converted into fractions. Because they are equalities, these fractions are effectively 1 divided by 1. Okay? Except at the same time, they bring in that unit, and that unit allows us to switch between different unit systems. And that's pretty cool. Okay? So that's why we go through and use our conversion factors. So what is the process? I think our textbook actually does a pretty stellar job of showing what that process is, though they do kind of struggle with the implementation, and it's the implementation that's really the biggest deal. And that implementation is because you have to go at it stepwise and slowly reveal that information. And when you look at an answer for how to solve something, you never see the stepwise process. You see the whole picture all at once, and therein lies the problem, because then what a student tries to do is duplicate that whole process, okay, or the whole thing. You should be duplicating the steps behind it. So, a couple ways that it can be called: dimensional analysis, or the unit analysis method, or the factor label method. They're all ultimately going after the same concept. Okay, so we're going to really push 3 steps behind this. Step 1, identify what you're trying to solve for. Okay, and in particular, this means the unit, both the measurement unit and the substance unit if it's important. For this particular section of our class, we don't really have a substance unit to worry about. So our calculation gets a little bit easier as far as our work goes, but it's going to swiftly come back. So make sure you consider that when writing things out. So measurement unit and substance. The next step can be easy or hard depending on the question. In this particular section of our course, the next step is usually pretty easy because you're usually only given one piece of given information. So you now just put that one piece of given information into your expression on the far left-hand side of your page. Okay? And you're now almost done, because step 3 is now putting in the unit factor, which is really just those fractional conversions to convert the unit that you have on the left so that it looks like the unit on the right. And that's it. So if we looked at a kind of a simple example here, so let's go ahead and do the fun stuff. And we attempt to solve this. What is the mass in grams of a 325 milligram aspirin tablet? Okay. Well, first off, what are we solving for? We want to know the mass in grams. There's our measurement unit. Officially, we do actually have a substance tied here. We're looking for aspirin as our substance. Because we aren't converting aspirin into anything else, usually we can get away with kind of cheating and ignoring the fact that the aspirin is there. But it is an implied unit. It's a good idea to keep it. The next part would be, what is the given information? And in this case, it's that 325 milligram aspirin tablet. My recommendation used to be that we would write that on the far left and leave all of this empty space. The problem with that, kind of from a logistics standpoint, is you don't know how many conversions you're going to have to run, which means your empty space could be way too large or way too small. So I'm going to argue, instead of going left to right, we go right to left. So we're going to start with our first kind of fraction on the right-hand side, and I now need to place this given information somewhere in this, either in the numerator or in the denominator. Well, how do I decide where to place it? Because it's really just a 50-50 coin toss on how to place it. Right? The best trick to figure out where to place it is to identify what you're given or what you want, which was mass, and that was placed in the numerator of the fraction of our answer. For those people being like, I didn't see a fraction, there's always a fraction. It just means there's 1 in the denominator. So mass needs to appear in our answer in the numerator, which means in our work, the left-hand side, mass also needs to appear in the numerator. Well, what is milligrams a measure of? Mass. So that allows me to then go through and say that I want milligrams in the numerator. What do I want to have appear in front of the milligrams? Well, what appeared in front of it in the given information? 325. What should show up in the denominator? Well, if we look at this given information, what shows up in the denominator? Well, nothing. There's nothing in the denominator. So it's an implied 1. Okay? If we now try to go through and compare units, milligram is not the same thing as gram, so I need to bring in a conversion. To bring in that conversion, I'll put something to the left, and that conversion needs to somehow fix the problems that I see. Problem number 1, I have milligrams in my left-hand side. I don't want milligrams, so I need that unit to cancel. So I'm going to place it in the denominator so that the units would cancel. If that cancels, fantastic. I've now gotten rid of that unit, and I didn't want that unit in my answer. But my answer has grams in it. Well, I need grams then to appear on my left-hand side of the equation. So I'm going to put grams in the numerator. Why am I placing it in the numerator? Well, because when we look at our answer, where does grams appear? In the numerator. Okay, so now the question that needs to be asked is, does that conversion factor exist? If it exists, then I can now put in the numbers associated with it. If it doesn't exist, that's when I'll have to say, well, what else could I convert to? And that becomes more challenging. Okay, and we'll see that potentially show up in another example here. So, does it exist? Yes. You were told that the milli x unit equals 1 times 10 to the negative third x unit. Okay, the x unit in this case is grams. 10 to the negative 3 goes next to our grams, because the 10 to the negative 3 in the thing that we were told to memorize is next to grams, and the thing that goes in front of milligrams is 1. And we now have the expression that allows us to now solve. For those people that went through and said, well, I did that a whole lot faster, you did that a whole lot faster because you didn't talk through all the freaking work. Talk through all the work and explain why you placed the things where you did, and you're going to be at the same 8 minutes that I've gone through for this expression. A lot of other people will say, but I could have done this faster by just shifting decimal points. That is a phenomenal way to do this if you're running a repeated conversion between grams and milligrams. But what if we switch it to now grams and centigrams, or grams and kilograms, or grams and teragrams? You have to memorize each of those conversions. Okay? Or what if we switch, heaven forbid, from grams to liters? If you don't have a process behind it, because that's not just a shift of a decimal point, if you don't have that process, you can't apply it, and you must learn a new memorization. And that becomes the problem with this. This particular unit, and my discussion here, isn't so that you can prove to me that you can do this conversion. I know you can. I have 100% confidence you can. But in the next section of our class, I am not confident that you can do those conversions. So what I want you to do is spend this section practicing this process that I'm telling you to do, so that when we move to the next exam and you don't have this ability to just shift decimals and be like, ta-da, I have the answer, that now you can actually solve it appropriately. And that's the point of this unit. Not, can you do this calculation? I have every confidence that you can. What I want is you to pick up a process so that you don't fail out the rest of the semester. So please work with me, do the process. To that end, we've got another conversion here. So you should go through and attempt that. Click that pause button if you will. Since you've gone through and solved it, we can now go through and write out our work. We want the mass in micrograms. Our micro symbol is that mu, right, which is a Greek letter. Given information, 325 milligrams. Note I'm placing the mass numerator. If we set up my conversion, I want to get rid of milligrams and I want micrograms. That conversion is not one that is explicitly given. Okay? And in this particular case, what I would tell you is that your microgram was 10 to the negative 6. Okay? So we've now got our setup behind this process, and we're probably about to get knocked on in the door here in a second. So I don't have a direct conversion, which means I'm going to have to convert milligram to something else. In this case, I'm going to go ahead and take it to grams, because then I know power of 10, 10 to the negative 3, goes with my core unit, grams. 1 goes with my complex unit. This does solve one problem. Milligrams cancels, but it doesn't cancel or bring in micrograms. It does bring in another problem though, because it brings in grams. So I need to get rid of grams and I need micrograms to appear. That conversion is explicitly given to me now. 10 to the negative 6th grams, core unit, 1 microgram. If I look at my units now, my units cancel out and the only unit I would have left on the left-hand side is microgram, which means now I can run through the calculation to solve this out and I could get my final answer. The final answer that comes out of this, assuming I aligned everything correctly, I believe comes out to be 325,000 micrograms. So if you enter everything into your calculator correctly, you've got that nailed down. I'm going to have to do it at a much later date, but I'll try and get a calculator video so that you can see how those powers of 10 manipulate through there. Okay. So hopefully you're starting to get the idea that you can do the process behind this. How important is this, or how challenging is this process? Allegedly, the French built a tank. The US companies were like, cool, can you give us the license? We'll build the tank and sell them to you. Right? Make lots of money. The problem was that the American industrial complex wasn't built for millimeters. And so when the unit systems came out, we couldn't actually pay or build those units. So we just had to give up on building that tank. Right? So it is a big deal. And once we've machined instruments into one particular path, it's very hard to convert between them because the instruments themselves don't allow a quick conversion back and forth. Right? Next issue that comes out, clearly not everything is metric. That's why we talked about English versus metric as in that meme in the back. So or in the last slide. So we've got English to metric conversions. These things become a bit challenging, which really stands out when we look carefully at the footnote. Each of those conversions is assumed to have 3 significant figures. Yeah, sig figs comes back. This one has 3 sig figs. 3 sig figs. And then this one's infinite because it's the same unit. Okay? But these kind of between unit systems conversions are assumed to have 3 sig figs. What if you have a conversion or a calculation that you need 5 sig figs? Well, then you have to dig out and find a conversion factor that is accurate to 5 sig figs so that you don't lose that information. That's kind of a big deal. So you might say, well, that's all well and good, not a big deal. At least we consistently know we have to go out and look at those because they have X number of sig figs that we would have to look at. The inch to centimeter conversion ended up being so freaking common that somebody finally just sat down and said, enough is enough. We're just going to define it. Right? What does that mean, though? How many sig figs, then, have to come in that conversion factor? Remember, I said it's defined. Since it's now defined, that is an infinite number of sig figs. But if I look, say, at a yard to a meter, that's not infinite. Okay? So depending on the conversion system that you're looking at, you may end up with more or less kind of significant figures popping up in your answer, and you end up with weird rounding errors. So we get lots of issues on converting between two different systems, and so we have to kind of watch out for that when we manipulate them. Which gets us to this last question, but gets us to our question. Let's do a conversion. The length of an American football field, including the end zones, is 120 yards. What is the length in centimeters? So if we were to set this up again, I'll walk you through the first two steps. Our final answer, we want centimeters. Okay. Step 2, identify what we were given. We were given 120 yards. I'm placing them both in the numerator, okay, as units, because those are both measurements of length or distance. Okay. So now the question is, how do I convert yards into centimeters? So the first thing I would attempt to do, yards in the denominator, so the yards cancel, and then I want centimeters in the numerator so that I would get to centimeters. And we again ask ourselves, does this exist? No, okay, at least not easily found. Okay, for those people being like, but I can go to Google, yes, you can go to Google. And you'll probably end up getting the answer wrong, as you'll see in a little bit. Having all the work to support your process is going to become a big deal. This kind of question, if it shows up on an exam, would be a show your work. So I could care less if you get the answer right, but your work sucks. So you're going to have to show your work for these kind of questions. It's not just punching it into Google. So centimeters to yards, not there. So I'm going to have to convert either centimeters into something else or yards into something else. This is literally a personal preference. You get to decide, which means there's at least two pathways to go through and solve this. Okay. For my sake, I'm going to go through and say I want to start cleaning up the units. So I want to get rid of yards. So I'm going to convert yards into, well, the first thing I see here is feet. So I'm going to go into feet. The number that goes in front of the feet comes from my conversion factor. So the 3 goes in front of feet. For those people that might have said, well, 3 goes on top. No, it does not. 3 does not always go on top. It will always go with feet. So the language that you use to explain how you're solving things will have a massive effect on the end result and your consistency in applying your conversion process. So make sure you're careful with that language. What goes with yards? 1. Okay, so I will leave you to now kind of go through and solve this out the rest of the way. You can either do my yards and feet, or you could have switched it up and do centimeters or whatever other conversion you want to go through and do. But again, show your work through that whole process. Since you've now gone through and spent the time to show your work, we can finish this out. I don't want feet. Okay, I look at my conversions. I don't see centimeters as a conversion, so I'm going to go to inches. Okay, in my conversion, 1 foot equals 12 inches. Where should the 12 go? It does not go on top. So if you were the one that said it goes on top, you're doing that wrong. It goes with inches. Okay, associate the number with the unit, not the location, because the location will change. 12 inches, 1 feet. If we go through and look, feet cancel. Okay, I need to bring in inches. Centimeters is what I want. Where do I find that conversion? That's up at the top. 1 inch, 2.54 centimeters. I can now punch it into my calculator and try and get an answer. This becomes an interesting question to talk about, and it's actually why I bring it up. And because I don't have a calculator, I'm going to have to kind of cheat. And if you figured out my cheats, great. If you haven't figured out my cheats, don't worry about it. 10,972 centimeters is a result of one of these conversions. There's another conversion process for those of you who are like, oh my God, I didn't get that. You might have gotten 10,968 centimeters. Okay? Well, depending on which conversion factors you use, you get to two different answers. Well, dang, that's unfortunate. So which one is correct? Awesome, good question. Neither one is correct. What? You just went through this huge long process to solve all these things out, and you're telling me now that neither of those answers is correct? Yeah. Okay. Why? Okay. Remember, when we go through and solve a calculation, we need to make sure that we do not add or remove information, which should be a tip-off that what you need to be looking at would be the number of sig figs. And for those of you saying, but there are 5 sig figs in each of your answers. That's true. How many sig figs are in the question? Only 2. That 0 is not significant because there is no decimal point. With only 2 sig figs, my answer can only get reported to 2 sig figs, which means both of these answers boil down to 11,000 centimeters, where those zeros are not significant. You want to make sure that you don't see those zeros and potentially get them confused as being significant digits. 1.1 times 10 to the 1, 2, 3, 4, because it's a big number, positive centimeters. Lots of intricate pieces fall into this. We have to be pulling at content from the entire spectrum. Okay? So please be aware of that when you go through and solve conversions, particularly if you're like, I can just punch it into Google. Google doesn't do sig figs very well because you have to supply a lot of information about the question. It just doesn't make sense to have a program calculate that when a human can calculate it probably faster than the program, as long as the human does the calculation. Okay? So if we rely on our computer programs to do it for us, that's where things fall apart. Okay? So make sure you go through and appropriately account for your sig figs. We're not adding or removing information in the process of solving it. For those people screaming, but it wasn't 11,000, it was 10,972, you've added information to that we didn't know about. Maybe the end zones isn't 120 yards, it's 121. Is that going to change your answer? Maybe it's 129. Is that going to change the answer? So the exact specifics of that have to show up in your measurement. And if they aren't explicitly there, you can't put them there. Don't do it. Okay? So, next thing. Sometimes people will go, I'm just going to worry about Google and I won't stress about sig figs, because arguably the sig figs aren't going to be a big deal. But your conversion in Google is only as useful as Google's knowledge of that conversion. What if I make up a unit, say Meeks to Stoops? Feel free to Google this. I did. It doesn't exist because I made it up. Okay? And I'm not popular enough for the internet to have posted an answer for the conversion of Meeks to Stoops yet. Okay? I say yet because eventually I'm sure that's going to happen. Okay? So you have to have a process that would allow you to solve this. And if you don't have that process, you're dead in the water and you end up just guessing. Okay? This is a relatively easy one because there's really only 2 potential answers. It's either 3.4 divided by 4.5 times 10 to the third or multiplied by 4.5 times 10 to the third. So 2 answers really become valid, okay? Because it's really only the placement of 1 conversion. That's why we have to be a little bit more careful with our processes, because in that case, it's so easy to just guess and eliminate most of the answers. Every conversion you do is a 50-50, which means on a multiple choice test, you're probably doing at least 2 conversions, which means your odds drop to 25%, which is blind guessing on the question. Okay? You should be able to convert this one on your own if you've got questions about it, or heck, you're like, I think I got it nailed, post it to Piazza, let everybody take a look at it, critique it, and we'll see how that work stacks up. Okay? I think that would be a really good use of Piazza, is to show that practice. We got another potential kind of system we could look at. Harry wants to exchange pennies, dollars. You can go through and look at it, and it's this big, awful, long word problem. And this is effectively a conversion problem. Okay? It's the same process. you were taught these kind of things in math, okay? And they always seem stupid. Harry could just beat up Douglas, take Douglas's money, take Sally's money, and he's just got tons of things. Okay, so why are we looking at a question here? We're looking at a question like this so that when we move into a new environment, say chemistry, when we start introducing units of moles and atoms and molecules, you know how to do that conversion. And you don't have to be thinking about both what is a mole, an atom, a molecule, and how do I do a conversion. But instead, it's just, I know this is how I do a conversion. Now I'm going to spend some time thinking about what those units mean. Okay, we're doing two things at the same time, both a here's a process and meaning. If we wait for the meaning to solidify in, you don't have the ability to do any of the conversions, and the time it takes you to learn that content goes through the roof. Okay, so we don't have time to wait for you to figure either pathway out. You have to do both. This is why we talk about figuring out that pathway now. Right? The other thing that's fun with this kind of thing is you could just go through and do most of those conversions in your head. But if we switch it up to something bizarre and strange, it all of a sudden becomes this challenging question. It's only challenging because you don't have that process. You need to write out what those equalities are, what those conversions are, what are we solving for, and how to establish those conversions. So again, this would be another example that I think would be fantastic to drop into Piazza instead of me working through it. Okay, so if you've got questions about it, start putting some pieces together and be like, this is as far as I got, post it to Piazza, and let's see how people can help us get through that. Okay, so this one I will actually solve out because this one's a little bit more chemistry related and is a really big deal because it's got a lot of moving pieces in it. This is a third unit. This is the next section of material. But this conversion is just following the same process we've already talked about. And if we make some simplifications to the language, we can solve it now without having any concept of what the hell a Sagan is, a molecule, a mole, or for that matter, grams in caffeine. So let's go through and see if we can actually create this process to go through and solve it. So step one, what do I want? Okay, so I do have to go through and look at this and decide what I want. I want Sagans of molecules. You'll note that I'm already starting to make approximations. I could even write in caffeine, but again, in reading the question, I'm not changing the substance, so I'm going to cheat a little bit and not show caffeine. Okay, and then I wrote MLCS to represent molecules. For those of you asking about mole, this is the perfect reason why we use MLCS and not MOL to represent molecule, because if we look through our conversion, we have a unit of mole that is clearly not referencing molecules, because a molecule of molecules makes no sense. Okay? So Sagans of molecules is what I want. What am I starting with? Grams. Well, Sagans, I don't know what that is. Molecules is a particle. So maybe I'm looking at particles, okay, and the numbers of particles. This becomes challenging because this is a mass. So that measurement unit isn't the same. But remember, what was that implied unit out here? That was caffeine. What's the substance unit with this mass? Caffeine. So while I may not know what the measurement unit is, the substance unit can tip me off on where I want to place it. I want to place that grams in the numerator because that's grams of caffeine, which is going to place it in the correct location for my final answer. Okay, 0.0350 grams of caffeine. It's not per anything else, it's just grams of caffeine. So I'm going to place a 1 so it doesn't change the meaning. I now need to go through and decide, I guess that should have been in purple if I was going to color code right, 350 grams of caffeine. And I now need to move on to the next step. Well, I don't want grams of caffeine. I want Sagans of molecules. Does Sagans of molecules in grams, is there a conversion factor explicitly stated that has that? I see Sagans of molecules being tied to molecules, so nope, that doesn't work. Grams to molecules or moles of molecules, nope, that doesn't work. And this last one doesn't have either of those units, which means that conversion factor that I want so badly to exist does not exist. Okay? At this point, again, I get to decide, do I want to do grams or do I want to do seconds? In this case, I prefer grams because I want to clean up my unit system. I want that to cancel. So I'm going to go back up to my things up here and say, what do I want to bring in? Well, I want to bring in a unit or a conversion that has grams in it. Only one of them has grams. That unit relates grams to moles of molecules. The number 194, where does the 194 go? It does not go on the bottom. It goes with grams, which happens to be on the bottom. 1 mole of molecules, grams. Great, grams was canceled. So I move to my next step. The next step is I need to get rid of moles of molecules, and I want seconds of molecules. Okay, well, I see seconds of molecules, fantastic, being related to just molecules, not moles of molecules, so that doesn't work. Moles of molecules, cool, related to just molecules, also doesn't work. So the conversion that I'm looking for is yet again not available to me. So that means I'm going to have to convert to something else. Okay, what do I want to convert to? Well, I again like canceling my moles of molecules, so I want to cancel that. Which of my conversions brings in moles of molecules? It's this one. That relates moles of molecules to molecules of caffeine. Fantastic. The number that needs to go with this. Well, 1 mole of molecule, the 1 should go with the moles of molecules. This big old long nasty 6.022 times 10 to the 23rd needs to go with molecules. There's that placement. Did this at least finally, maybe, hopefully, get me to my answer? Well, let's take a look. Is molecules the same thing as seconds of molecules? Well, no, I'm missing the term seconds. So what I need to do, molecules on the bottom, seconds of molecules on top. Please God, does that conversion factor exist? Seconds of molecules, thank you, to molecules. Fantastic, there it is. I now have my conversion. The 1 goes with seconds. The 4.00 times 10 to the 9th molecules goes with the molecules, which would be down below. Now we could go in and punch it into our calculator because our units are aligned to go through and cancel out, and everything should be sweet, beautiful, and gorgeous. The one sweet, beautiful, and gorgeous thing that I do not happen to have with me is a calculator. Okay, so this would be an awesome another post to Piazza with this is the number I got. To give you an idea on how I would approach this, I would take 6.022 times 0.0350, okay, and I would take the 10 to the 23rd and pull that out. Then divide this 4.00 times 1.94, 194, and that 10 to the 9th I would pull out over here. Okay. This number thing is what I would throw into the calculator. Okay. Arguably what I would try and do first would be to convert this piece through those approximations that we went through and talked about with our math. This is the same thing as 10 to the 23rd times 10 to the minus 9. Powers of exponents, this is 10 to the 23rd minus 9, which would mean 10 to the, theoretically I'd be able to do that calculation better in my head, but 14? 10 to the 14? I think I did that right. I could now actually go through and look at my answers and maybe eliminate all the wrong ones, because I should be ballpark, remember, ballpark 10 to the 14. So if I'm seeing a 10 to the negative, wrong. If I'm saying 10 to the 5, probably also wrong. That really does depend on the size of this calculation with the numbers over here. right? But I now have that kind of ballpark estimate for where I should be with my final answer. Okay? So again, Piazza is a great place. Go ahead and post what you think you got for that answer on that. And then we might hopefully be done. Yeah, we're done with this one. So I hope you were able to go through and do some of those. Again, remember, the big deal with all of this is that process. I can't stress this enough. Step one, what do you want? Okay. Step two, what do you have? Step 3, 4, 5 is convert what you have into what you want. Okay? So it's all about what do you want and what do you have? What do you want? What do you have? Okay? And it's that process all the way through this. This, believe it or not, applies to life as well. I heard a lot of people want to go to nursing, okay, or become a nurse. You have to make it into that program. So what you want is to make it into that nursing program. What do you have? Perhaps you have the will to get there. What do you not have? The prerequisite courses. So you now have to use your will to get through the courses so that you can get to the nursing program. You're doing these want, have calculations, if you will, in your head as you move through not only this course, but everything you're doing in life. If you don't know what you want, all of your actions could very well be useless. So you need to have some idea of what you want so that the courses you're taking take you closer to that goal. If you don't have an idea of what you want, the courses you're taking could be taking you the opposite direction, and that's not good. Okay? So spend some time both in our conversions to figure out what we want, what we have based off of those questions, and also maybe reflect a little bit back on your life and life experiences and decide, what do I want? What do I have? How do I do those conversions? Right? Some of those conversions happen because you reach out to your faculty and your instructors and your teachers and your family to help you make those two things, have and want, align and be the same. Okay? So with that, have a good, have a good rest of the day. I'm confused. I got kids screaming everywhere. Bye.